We talked about the importance of the System Development Lifecycle, or SDLC, at the beginning of the book. There are two general approaches to the SDLC. First is the predictive approach. Predictive approach is sometimes called the waterfall model. The waterfall model is a sequential approach where you have phases that begin with planning and then go to analysis and design, etc. And it assumes the project can be planned in advance and that an information system can be developed according to that plan without having to make any changes as you go. The adaptive approach to the SDLC is an iterative model. The iterative model is the one that we're using in this text. The adaptive approach assumes a project must be more flexible and you have to adapt to changes that are needed as the project progresses. So requirements and needs are more uncertain, and there's higher technical risk involved in the project. In practice, most projects fall somewhere on a continuum between needing a predictive and an adaptive SDLC. For example, this figure shows a balancing beam with, on one side, you have predictive SDLCs. Requirements are well understood, very well defined, there's low technical risk. At the extreme, the project can be completely planned out in advance without any concern about needed changes. On the far other side, the adaptive SDLC, requirements and needs are highly uncertain. There's a lot of technical risk involved. Somewhere along this is where typically a project will be defined. This shows a traditional predictive waterfall SDLC. This is the approach to SDLC that's been used from very early age of information system development, meaning all the way back to the 50s and 60s and 70s. These would be typical phases you'd see in a waterfall SDLC: project initiation, project planning, analysis, design, implementation, and deployment. And so project initiation phase would be completed prior to starting project planning. And then project planning would start, and it would be completed before starting the analysis phase. So the initial planning specifications that are produced during the project planning phase would be frozen, is the term they use for that. So they cannot be changed. So you're committed to carrying out the project exactly as planned. And then we get to the analysis phase. All of the analysis work goes on, defining all the requirements, for example. And then when that's completed, there'd be analysis specification, and it would be frozen, meaning you can't change. And then the design phase would involve doing all the design work. And the completion of the design phase, all the design specifications would be frozen. And then based on that design, you'd go into the implementation phase and implement, meaning write the programs that would implement the design. And then the system is built and delivered exactly as specified and exactly as planned, and then there'd be deployment. The reason why this is called waterfall is at the end of each phase you go over the edge and there's no going back. And then you go over the next edge of the waterfall and there's no going back. You're committed to going from phase to phase. In practice, using the pure waterfall predictive SDLC is very difficult to do. Originally, this kind of life cycle approach was designed to be used for building a building or building a bridge, where it's very precise and everything can indeed be specified out in advance. Information systems deal with a lot more uncertainty, and they're all harder to plan out completely in advance. So in industry, a lot of organizations began using an overlapped approach, or overlapping phases, but still considering it to be a predictive SDLC. There's a little more flexibility, but it still assumes you're able to do predictive planning and have sequential phases. So in this example, you have project initiation and then a decision point where management approves the project. And then you go into the project planning phase and complete most all of the project planning, but then you still might begin some analysis work. So there's a little bit of an overlap between project planning and analysis. But there's a decision point here shown as the green diamond, meaning management approves the plan and then the project continues. And then you continue with the analysis phase, but you start doing some design, get things off the ground with design. And then there's a management control point where management approves the requirements. And then you complete design, but while you're completing design, you're going to start doing some implementation. And then there's a management checkpoint that basically approves the design. And then while you're implementing, you might do some preparation for deployment and do some actual deployment in parallel to implementation. And then there's a decision point saying, okay, the system is operation, now it's time to go in and do system support. Now, after each management checkpoint for project planning, there's additional planning that goes on, and there's the ability to make some changes as you go. And then after the analysis checkpoint, there's additional analysis tasks that continue on as well. After the design checkpoint, there's additional design tasks that continue on. So this is sometimes a practical approach to using a predictive SDLC based on the waterfall SDLC, but adding in a little bit more flexibility. The spiral model was the first adaptive approach to an SDLC. And the idea here was to get completely away from sequential phases, overlapping or not, and instead think of the system development project as a spiral. The way it works is you start in the middle and you plan the first iteration. So the idea here is we're doing multiple iterations. And then you go in and do some analysis and design, you construct the first prototype, you test and integrate what you have, and then you plan the next iteration based on feedback that you received from the first prototype. And then you go in and do analysis and design for the second prototype and construct it, test it and integrate it with prior work, get a lot of feedback on how well it's going, and then plan the next iteration. Do analysis and design, construct a third prototype, test and integrate, get a lot of feedback, plan the final iteration, do analysis and design, construct a fourth prototype, test and integrate, get a lot of feedback, and then finally you're done. The goal here is to have a prototype at the end of each iteration. In other words, something that actually runs that you can show people. So each iteration will involve analysis, design, and some actual implementation where you're doing some programming. Now, looking back at the SDLC used in this text, it's adaptive in that it uses iterations. And it shows core processes that go on that define different kind of work that has to be performed within each iteration. But rather than showing it as a spiral, it's showing it in sequential, where you have a sequence of iterations, and it allows the possibility of having management checkpoints after a certain number of iterations to keep management informed on how the project is going. So it's a little friendlier in terms of reassuring management that there's actually a plan for the project, even though it is quite adaptive. Recall that the core processes are identify the problem, obtain approval, plan and monitor the project, discover and understand details, which is much like analysis, design system components, which of course is design, build, test, and integrate the system components, which is basically implementation, and then complete system tests and deploy the solution. Note that there's actually some coding at the end of each iteration, so you're producing, in this case also, some kind of a prototype, some executable that can be run, that people can look at and evaluate to see how well the project is progressing. This particular SDLC is based on a system development methodology called the unified process, or sometimes the rational unified process. And you'll see later the full life cycle for unified process.